Alright, hello. We're going to do chapter 12.5, in which we are going to multiply polynomials. Now, to start us off nicely, we're going to multiply a monomial by a monomial. And we have a monomial, let's say 3y squared, and we're going to multiply it by another monomial, maybe 6y to the fifth. So here's our two lovely monomials. Now, what's going on between these two is multiplication. In fact, we have a lot of multiplication going on. We have negative 3 times y squared times this 6 times y to the fifth. It's all multiplication. And we could see these parentheses are only here to represent multiplication. So let me go ahead and just drop them, and I'll write my multiplication sign so we can see this a little bit nicer. Since this is all multiplication, we can use commutative law and reorder this to multiply it a little bit nicer, in which we can multiply like terms together. And what I mean by like terms, I mean same bases together or integers together. Like negative 3 times 6 we can do. We know negative 3 times 6 is negative 18. And when we multiply variables together, we have to make sure first that they have the same base. So this has y and that has y, we're good. And when we multiply, we add the exponents. So 2 plus 5 is 7. So here's our result. Now you might be thinking in your head, what if it wasn't the same base? And let's go ahead and see what that might look like. Let's say, for instance, we had negative 3x squared times 6y to the fifth. So, once more, what we have here is multiplication going on. In fact, everywhere is multiplication. It's all being multiplied. So the beauty of that is that because everything is multiplication, there's no plus signs or minus signs to screw it up, we can use commutative law, which says we can change the order in which we multiply. And when we look at this, we can multiply what we do know together, like negative 3 times 6, which you definitely know now is negative 18. But now let's look at our variables. We have x squared times y to the fifth. Well, x and y are not the same base. We can't do anything with them. If they're not the same base, we can't combine them. So it just stays x squared y to the fifth. And there's nothing more we can do about it. So that's two monomials being multiplied together. Let's go ahead and see what happens when we take a monomial and multiply it by a binomial. So let's have a nice monomial. Let's say 5n to the fourth. And we're going to multiply it by n squared plus 3. So this is our monomial, 5n to the fourth. You can view it in parentheses or not. It really doesn't make a difference. This entire thing's being multiplied by n squared plus 3. So this should kind of look familiar, like one of our rules, and I'm going to write it. Maybe you think of the name, where you have a times a b plus c, and you take that a and you distribute it to each term, so that you had ab plus ac. Distributive law, right? So whatever's in front, this monomial, we're going to take it and distribute it to each term. So we have 5n to the fourth times n squared plus 5n to the fourth times 3. And now this is a lot of multiplication going on, so let's multiply same things together. We have 5 times n to the fourth times n squared. Well, same base multiply together. We add the exponents. And 4 plus 2 is 6. Plus, so you have to be careful because we're adding here from the beginning, just like our distributive law tells us to do so. Then over here we have multiplication. In fact, we could reorder this where we can see 5 times 3 first, and that n to the fourth is coming along for the ride. So there's our final answer, 5n to the 6 plus 15n to the fourth. Let's go ahead and do another one of those, and we'll see a little bit different. Let's say we have negative 2x squared times x minus 5. So we have something in the front. This is our monomial. and we have to distribute it to each term in the binomial. So we have negative 2x squared times x. Well, we have negative 2 times 1, which is still negative 2. X squared times x, really this is x to the first, so you do 2 plus 1 is 3, so you have x cubed. Now let's do the second part. We have negative 2x squared times negative 5, or you can think of minus a positive 5. However you see fit, do know that there's addition and subtraction going on here. So a negative times a negative is a positive, so now we're going to add. 2 times 5 is 10, and x squared is coming along for the ride. And there's our answer. So just make sure you remember distributive law. Let's get a little bit more complicated. Let's say we have a monomial times a trinomial. So let's say we got, we'll be nice to ourselves, 3x times 2x cubed plus x minus 5. Alright, so we'll take that monomial, and now we just have distributive law again, except we're going to extend it to every single term. No term is excluded. So everyone gets multiplied by 3x. So we have 3x times 2x cubed. Well, 3 times 2 is 6. X times x cubed is x to the 4th. Plus 3x times x is 3x squared. And then minus 3 times 5 is 15, and x is coming along for the ride. So there's our beautiful answer. Now, multiplying by monomials, all you have to do is remember distributive law. When we change things up and now multiply a binomial by a binomial, we can still use distributive law, but it's going to look a little bit more funky. So, we'll start off nice. Let's say we have x plus 3, times x plus 6. Alright, so using distributive law, we're going to take each term from the first binomial and distribute it to each term in the second one. So that means this x here has to distribute to the first term and to the second term. Same deal for the second term 3 here. Has to distribute it to the first term and to the second term. Everyone must be distributed. So let's see how this is going to play out. So we'll start with the first one I drew the arc to. X times x. Well, x times x is x squared. Alright, now let's go to the next one. We have x distributing to the next term, which is 6. So we have 6x. Now let's head to the green line. We have 3 times x, which gets us 3x. And then last but not least, we have 3 times 6, which is 18. Now we gotta be careful. Sometimes we end up with like terms, and if we're able to, we should combine them. So you might be noticing the 6x plus the 3x, which does combine and gets us 9x. So this would be our final answer. Let's see this a little bit differently. We call this distributive law here, where we distributed each term, but sometimes it's hard for students to keep track of that. So we give a name to it. We call it FOIL, in which the F in FOIL stands for first, the O stands for outer, the I stands for inner, and the L stands for last. So let's do the same problem. I know, a little bit boring, but we'll do it using the FOIL method. It's really the distributive method, just it's easier to keep track of things. So let's start with F, our first. So the first term in the binomial times the first term in the second binomial. So x times x, which we've done before, is x squared. Now we'll do outers. So the outside terms, well, an x and a 6, see how they're kind of on the outside of this multiplication? We'll take them and multiply them together. So we have 6x. Then we'll head our way into the inner, so like the inside of this multiplication, in which we have 3 times x. And finally, we'll do our last term of the binomials, 3 times 6, which is 18. Which you can see is getting us the same thing. We'll go ahead, combine like terms, and we got x squared plus 9x plus 18. So FOIL is just a nice way to keep track of the distributive law. There's another way we can do this. Some people might like this. If you're pleased with FOIL and you don't want to know anything else, go ahead and stop watching. But there's a picture way to remember how to FOIL. So let's go ahead, we'll use our example, x plus 3, x plus 6 being multiplied together. Now the picture way is a little bit interesting. So we'll start with like a box. And we're going to break this box up, in which I have x plus 3 here is the length of one side, and x plus 6 is the length of the other side. And if I multiply them together, I'm going to find the area, right? Here's our length, and here's our width. And the area of the rectangle is length times width. So there's the two multiplying together. Little funky, keep with me. So we have a plus sign. What I'm going to do is kind of break it up. I'm going to call the length from here to that plus sign x. And then the length from where I stopped all the way to the end is 3. Same deal over here. I have x plus 6, so where that plus sign is, I'm going to draw a little line across. This length here until the plus sign is what we would call x. I'm going to just erase that mark. And the length from the plus sign down is 6. So let's see, I can write a bunch of smaller little rectangles. I have x, this length here is x from there. This length is 3, this length is x. Same deal over here, I still have x from up above, and then 6 from the side. And then I have 3 and 6. So what I can do is find the area by taking x times x, taking 3 times x, taking x times 6 or 6 times x, and 3 times 6. And if I add up all the pieces of the area, I will end up with what x plus 3 and x plus 6 is. So x times x is x squared, 3 times x is 3x, 6 times x is 6x, and 3 times 6 is 18. And we'll go ahead, we can combine our like terms, in which we can see we got the same answer as we did before, x squared plus 9x plus 18. The box method is just a nice way to visualize the area that we're doing here, because we're multiplying a length times a width. So that's it for now.